I'm Drew. I'm here tonight as a Santa Cruz Works board member. My day job is at Amazon, where I work leading a developer marketing team for Alexa. Who here has an Echo device or is familiar with what that is? Who here knew that downtown Santa Cruz is where we build the app that runs on your mobile phone that sets all that stuff up when you've had it in your house, right here in Santa Cruz? We have about 150 people on 2 stories down there above O'Neill. Who in here works in the AI industry space today? Let me hear cheers. Let me hear you make some noise. All right. That's kind of modest. I mean, who here is a student or an academic who's here because their professor or assistant maybe told them to come in? I'm sorry, I can't hear anything. All right, a few. Who's here because they just got this in their email and they didn't have anything better to do tonight? Oh, geez. All right. What am I missing? Anything else that you want to shout out that you're here, that you're excited about? Who's here because they're just basically curious, and it's amazing that I'm sitting here with people from across the industry in downtown Santa Cruz, California on a Wednesday night. This is definitely a show. There we go. All right. So with that said, we're going to just kind of go back and forth and let this go. The reason that I love working in this space, I started out at AWS about 7 years ago. I jumped to Alexa about 5 years ago. So I have some rough background in the cloud computing space, enterprise storage, and I'm a product manager at Amazon building the tooling and the marketing technology systems that we use to take these ideas out to market. The exciting parts of what we're up to now, I want to let these folks talk to, because you don't want to hear from me. There's news every single day. What's the big announcement that happened today? Anybody? Shout it out. Gemini. Gemini is a third of some big players that we've already seen some on the slides today. Let's talk about some of that stuff tonight. So, thank you all. Why don't we start with you, Leilani? Who are you? And tell us again why you're here tonight.
So I'm here because I love AI and I teach AI, and I don't think anyone from my class is here, but you guys should take it. So I'm an assistant professor at UC Santa Cruz. I work on AI explainability, especially for complex systems.
Perfect. Thank you.
Hey, my name is Sasha. I'm with a venture capital fund called Playground Global, based in Palo Alto, California. I focus on AI, robotics, and next-gen compute. And apropos what Leilani was discussing earlier, I ran engineering at Zoox, a self-driving car company acquired by Amazon. I ran engineering at Cruise, a self-driving car company acquired by General Motors. So there's a theme there. And before that, I was 10 years at NVIDIA as VP software.
My name is Craig Vachon. I'm the CEO of AI Redefined. We're an AI company based out of Montreal, Canada, and we are focused on multi-agent reinforcement learning with continuous human feedback in order to add context to AI.
So we have the academic world, we have the venture capital world, we have the private sector, all sitting here telling us about how amazing this stuff is. That's exciting. So let me start with you, Sasha, please. Give us all a little bit, roughly speaking, how did we find ourselves at this incredible nexus of technology with like the chips, the cloud computing, the applications? Why is it all exploding right now?
All right, there's a lot there to unpack, right?
Roughly speaking.
How many hours do we have here? Yeah. All right, so when we, at our venture capital firm, thought about investing in AI a few years back, I wrote a white paper and I thought about how we got here, because you have to know how we got here in order to figure out where we're going. So specifically thought about about how it started as fiction, like we were imagining all these amazing things that can happen. And then it turned into a theory, like with, about the Turing test and all these things that happened. And, how we started formalizing all these fictional things that we thought about into mathematical models and symbolic models and so forth. And then suddenly, but I can give you a little more history there, in 2012, this thing happened called ImageNet, where all of a sudden somebody used a GPU, which is a graphical processing unit from NVIDIA, to recognize images of cats, dogs, hot dogs, and what have you, better than anybody else ever in the world by like 10%, which was a huge leap, because if you look at the graph of ImageNet over the years, like 1%, 2%, blah, blah, and all of a sudden, boom, hockey stick, 10%. What the hell happened there? Some guy from University of Toronto, Alex Treshevsky, famous for his AlexNet, figured out that a GPU is this massively parallel processing unit that can do matrix multiplications faster than anything else in the world, which roughly translates into pixels and elements on an image, and can do all this recognition quickly. And then everybody started paying attention, and all of a sudden NVIDIA becomes this hot thing, GPUs become this hot thing, all the research money pours into this, and fast forward today, we go from fiction to theory to something that's actually practical, and now productized. Next step is going to be trusted, and then eventually we get to something called general intelligence. But whether or not we get there, the fact that it's going to be productized, and we're going to talk about what that means for the rest of us, is just the most amazing thing that's happening on Earth right now in my mind.
Thank you. That's a lot. The accessibility of processors, GPUs, the availability of cheap compute in the cloud, a bunch of use cases that are actually applicable to this. Craig, what are you guys up to as you try to sort of put boundaries around how do we keep ourselves, shall we say, from going in the ditch as we develop all this stuff? That's a self-driving car reference. You all get it, maybe? All right. I'm trying, Leilani. It's hard.
I think what we're most concerned with and why our company was founded was around human-AI alignment. Finding and understanding.
Wait, human AI alignment. Unpack that a little more. Why do we care?
Because we don't want AI to hallucinate. We don't want AI to make wrong assumptions, to act without context. And because when it acts without context, it really kind of screws the pooch, right? The very famous Facebook engagement algorithm that increased engagement by 21%, but did so via polarization, hate speech, and misogyny. That's not human AI aligned. And so we developed a company where we are focused on multi-agent. So you're adding context with reinforcement learning. Reinforcement learning has rewards and punishments, so it learns much faster. And then with continuous human feedback, so that humans literally steer the AI in the direction we want it to go.
Fantastic. And so, Leilani, is that what's happening in your lab? Are you teaching the AI to be, do we require humans in the mix? Because that doesn't seem scalable.
So I guess the way that we think about a very similar approach is, so we're thinking about AI as a complex system built out of multiple parts, just like we are, right? We have things that are seeing the world, we have our eyes, we are listening with our ears, right? And you can think about a self-driving car that's making many different maneuvers. You could think about a human operator as a part of that mechanism. You could also think about that being autonomous. So we largely think about any type of complex system, and you can apply this to many different areas. When I got into the field, I was actually working on healthcare networks, which again, very similar type of complex system where you have a pharmacy, you have a doctor, you have a patient, right? And that same type of network structure you find in a lot of other AI applications that we're working on. So very similar approach, and I think that we need, we do need the human feedback, because currently without it, we're just going to get lots and lots of hallucinations. We're never going to know when we're right or wrong. So it's a very important part of the system.
Nice. Thank you. Thank you. So when Doug and I are out drinking beer, as we do once in a while, I'm fond of characterizing this as maybe one of the largest transfers of capital in human history. The amount of stuff that's happening and the pace is just mind-boggling and astounding. For let's just go down the line here. What keeps you up at night? What worries you about this? Like, this is kind of an unringable bell. Once it goes out there and happens, we're all on board for this, whether we like it or not.
Oh, in terms of AI?
Yeah, what scares you?
Oh, self-driving cars. No, I mean, I think that the big thing that I'm scared about, and this is also directly related to the research we do, is the fact that a lot of these AI models that we're talking about today are not explainable. They can't explain what they're doing. And when they either hallucinate, they make up information, or when they're wrong, they have no way to be able to say what happened, why, and how to fix it. Unlike humans, right? Even if we don't exactly know what's going on, for example, if we're feeling sick, right? We can start to tell a story, oh, my stomach doesn't feel well, oh, my nose is a little bit stuffy. And so I'm always thinking about the fact that how can we hold these machines accountable for human decision-making if they're not explainable?
Sasha? Yeah.
When I think about what worries me, like, there's two ways to answer that. One is kind of in a positive, optimistic way. Like, there's so much going on, so many amazing founders and technologies happening, fear of missing out on what everybody else is doing and how, some advancements that are happening. because I get blown away on almost on a daily basis when founders show up from, whether from universities or other companies, like with the ideas they have. It's like, wow, we got to go build that, and just want to be part of that journey, because having been in Silicon Valley for 30 plus years, you have to be in the right place and be on that train, the next train that's going to do the next amazing innovation. But on the more negative side, I mean, just echoing, the guardrails that we need to put on this technology. Ultimately, AI is a tool. Applying that tool to the right jobs and not to the wrong things where the unintended consequences can happen. Hallucination is kind of harmless when it's in a chatbot, but hallucination when it's in a mission-critical system, whether it's a rocket or a self-driving car or a medical device, can be deadly. So we just can't apply this tool to use cases that are really not ready for it, or the tool is not really built for yet.
I'd like to expand on that, because I think the greatest risk of AI is sort of a human over-reliance on it to become sort of our panacea to solve all these potential challenges and problems. And I think it is very much a nascent industry with a lot for us to continually learn and teach AI, and we need to be at a place. I think back to early on in ChatGPT, I think it was last November, when it first launched, there were lawyers who were using it to cite cases that didn't exist, right? That reliance on this is humans tend to be lazy. And in our laziness, we tend to trust things that perhaps we shouldn't. And so we need that human feedback in order to keep it on the straight and narrow.
Okay, then who's driving the ship? Should we let our Congress make these decisions for us, or should we let those of us in the industry make the decisions for us? And there's probably pros and cons to each. Craig, let's start with you. Please don't say Congress.
I think Congress and many regulatory environments are going to be so far behind that they will never be able to, effectively regulate this. If we look at, Gemini this morning and its multimodal approach to voice and written word and vision, yesterday none of us would have anticipated such a breakthrough. I mean, it was literally this morning. And so, getting Congress to be able to regulate that probably isn't going to happen, but it reminds me of we need a mechanism by which that we can continually steer AI, or we are going to be left in awkward times.
Yeah, so I don't think Congress should regulate. I think, honestly, to be blunt, it should be left to private markets, because the incentives in private markets are the correct ones, where companies are incentivized to do the right thing, or else they will shut down, or consumers will not go to them. Congress is not equipped. I think it's okay to provide guidelines and policy, stick to policy rather than regulation. For example, an example of good policy: let's not do gain of function research, for example. So look at the use cases for AI and say, let's not go in that direction. Let's not clone humans. So something applies a similar approach to AI, but don't do what the recent executive order did. Was you can only use this many cores, or this clock speed, and things like that. That makes no sense, because technology moves so fast, software moves fast, algorithms move, so that doesn't really accomplish anything. It slows some things down, and there's regulation in NVIDIA, for example, what it can sell in China, and Congress spells out the specs. So NVIDIA just builds a chip that's just below that spec, so it doesn't really get us anywhere. I really believe that private markets are incentivized to do the right thing, and companies that do the right thing will be rewarded.
So maybe I'll answer a slightly different question of what I think would be nice to have. So I think something that would be nice to have is to have something like the FDA, but for AI. I would love to see something like, nutrition facts for artificial intelligence based on the risks and based on the application you look at, right? I don't know how many people have bought a new car recently. Maybe some people, I just did, right? And they're telling me about all the wonderful capabilities of what the AI can do, right? But they don't tell me about any of the risks of what the AI can't do or what happens when I get in an accident, right? And when you are picking up food at the market, you are able to make that decision for yourself, right? You can interpret the food label however you want and make the decisions that you can. And I think we need a similar thing for artificial intelligence. I don't think that necessarily it should be done by Congress. I think that maybe thinking about some regulatory board would be really important, but I also think it depends on the application and the risks that are.
Thank you. A label on every package that says nutritional values. Let's see. We talked about what makes you concerned. What's the most exciting thing that you've come on or come across, or particularly as you've had lots of pitches from firms or looked at places, or even ideas from your graduate students? What things really get you like fired up? Like this is going to change the world.
Sorry. Maybe I'll start in a slightly different area because I work in education. I mean, I think the students, I know there are several UCSD students, but they're so inspiring and so excited about this. My AI class has gone from when I started at the university, 60 students. Now we've almost tripled the number of students in my class. I think that they're super excited about this. They know how to use the tools. I'm always telling my students, I would love them to use ChatGPT for my class. Show me how it helped you do your homework. I think about it as a tool. So I think that there's a huge amount of opportunities, and I think especially in education, thinking about how AI can help us educate the youth better is just a really exciting area.
Well, what's truly exciting to me is that we're entering this era of co-pilots. Like all our capabilities are going to be so amplified with AI. Even somebody that's half expert at something will all of a sudden be a superhuman at something. And that's what AI brings. It has so many implications across academia, across different skills. An electrician that has some basic training, maybe with AR glasses and AI, will all of a sudden be able to fix anything in your house, even that refrigerator from 1947, because AI will figure it out for them and tell them exactly which part to replace or what to do with it. And that applies to medicine, to trades, to education, to white collar work. So that excites me, and to see founders who are actually working on those tools, and also the less sexy but truly enabling and transformative things that are on the infrastructure layer and the enabling layer, like the compute layer. Earlier I mentioned next generation compute architectures, because even GPUs have a limit. The little secret is how much power they use and how much heat they generate. So all the new innovation that happens to actually enable the scale of AI, so we can do a lot more with existing data centers, with existing power sources, instead of building more power plants and more data centers and so forth. So those are things that actually will transform infrastructure for the next 10, 20 plus years, as opposed to what we see at the very end, a co-pilot for email. There's so much behind that has to happen. That's core, unsexy technology, but none of it would be possible without it.
I'm going to contradict Sasha in the sense that he talked about one of the fears was perhaps cloning human beings. One of our most exciting projects is to create, with one of the largest pharmaceutical companies in the world, we're creating digital twins for every human being on the planet. And we're doing so by taking your DNA, we're combining it with your biomarkers and your wearable, and we are creating a digital twin where we can literally test billions of different options, so that when we prescribe medicine, we're prescribing medicine by understanding exactly what you as a human being are most going to benefit from. And we can do that in minutes, as opposed to my wife going through menopause, and she went through about 18 months of different hormone therapies before they finally got it right. With this kind of tool, you simply put it in the digital twin, it tests billions of different options, and instead of prescribing 25 milligrams of whatever, it says 18.5 milligrams is the perfect solution for that specific human being. That, to me, cloning human beings in a digital world is pretty exciting.
Would you want to have 2 physical wives? That's the cloning I was talking about. Yeah.
One wife is enough for me. Doug, should we do some Q&A? How are we doing on time? Oh, well, then he says yes. I can. Yeah, I got a hand right here, and the lovely lady in the blue shirt there. Thanks, you guys.
Thank you so much. I am not very familiar with AI. Thank you. My name is Vicky. Thank you very much. I'm not very familiar with AI and LLM, and I should be. But I should be. But I do have a question specifically about understanding that a lot of these data models are being, or AI is being trained on data models being created by humans or out there, right? But what if the data is corrupt? Or I read an article today that a lot of professors are self-censoring about any ideas they have, any thoughts they have. For example, the conflict in the Middle East, genocide, so whatever. So if the data is missing, or if it is tainted in some ways, would the AI take science in a wrong way or come up with different or wrong solutions? And that's maybe a question to Greg or anyone.
Sure. I think, LLMs, like any tool, can be misused, and it's only as good as the data that comes in. I think what makes the most sense, though, is that we start to train our LLMs based on behavioral as opposed to self-reported feedback. And behavioral in the sense that if I take something from an LLM as after I've prompted it to ask it a question, I get something back, and I take that information and bring it to my email, but I change 6 words in that resultant paragraph. That becomes the feedback loop for you as an individual, and maybe as an organization. But I think that's the way that we steer this, so that we find that right solution, because I don't think we'll ever decide as a human race exactly what the right words are depending upon your perspective. And so I think from the perspective of a great LLM, it should be about what it is that it should augment you, not spout the most politically correct or appropriate words.
I'm not sure if you.
Maybe I didn't understand.
What I'm asking. What I was saying is that if I want to use AI to do some research, for example,
Right.
but it's based on the data that's out there, and the data is either self-centered or someone's head and they're not going to put it out there, or it's biased or it's misdirected. How does it, and that's when you said there should be a human co-pilot or whatever to observe that or whatever. So how do, and humans are lazy and you just kind of trust whatever it says, or then read whatever articles Google News tells me, and not, don't do my own research, whatever. So how do we make sure that the data that it's being trained on, for example, if I want to write a research article, how do I make sure that it is getting all the right data, not the sanctioned, for example?
Yeah. I think it's about prompting the LLM with the right question. And that is, give me an unbiased look at this question, right? And I think that Microsoft OpenAI has these kinds of tools where you can unbias certain reporting and the like. It's not, people will still be the judge of that, and I don't think we can change that.
Yeah.
Let's get one more opinion on that.
Oh, I was just going to say very quickly, that's a very difficult problem. I think one of the difficulties too is that we don't know exactly what data these large models were trained on.
Yeah.
I think that makes it very difficult. A lot of the work we do in my lab is also related to ethical AI. My PhD student, Jack Fox, is working on exactly this problem. How, can you basically fool an LLM into telling you one side of the debate or the other side of the debate. And there are ways to do that, or what is truth. But I think it's a very difficult problem, and a lot of people are working on it. But part of the problem is that there's no transparency with the data collection, so we don't know.
Let's take right here in the corner.
Oh, go ahead. Back in the class. Okay.
I'm not in one of your classes that I actually graduated, but found your research very interesting, and I wanted to know what technology are you using for AI explainability, for like decision analysis of like the neural networks and deep composing.
Yeah, we do a bunch of different approaches. I'll just highlight a few. So, I mean, one thing that we use, and I mean, for anybody that's maybe been in the field longer than me, a lot of what we use is just rule lists and decision trees, which end up being explainable by design. And they're something that all of us do, and they're very similar to human reasoning. I think for, so some of the stuff for explaining deep neural networks, we work on clustered compositional explanation. So we come up with ways that you can cluster specific neurons that are looking at higher level concepts. We have a paper in NeurIPS that's coming out next week. Just a plug. But we work on a lot of different explainable techniques. And actually one of the big things we do in my lab that's different than other explainable AI labs is we compare the different explanations, because explanations are all explaining something different, right? I just met you. If you asked me how I'm doing, I would say, fine, right? But if my best friend was here and I said, fine, that would not be an acceptable explanation. So one of the other things we look at is how explanations disagree. And again, we do that using interpretable methods like decision trees, rule lists. But I can talk more after as well.
Yes, sir, in the back, the gray shirt. Oh, sorry. Too excited. Thank you. Thanks, the band.
My name is Will Wiseman. Kind of curious question. It was an iteration on the very first question. So I worked in AI previously for energy system optimization, helping energy producers bid into markets more efficiently. Lots of upside on that problem. Now that I work more in finance, I can fund clean energy projects and want to apply AI to that analysis of those assets and cash flow that will generate. So thinking about kind of the underwriting process there, as we kind of look at maybe this horizontal industry mortgage underwriting, there's been a lot of kind of embedded bias into that industry, particularly with redlining and whatnot. I'm curious how you think about, Craig, you mentioned garbage in, garbage out. How is it that we have such extensive data sets? How do we pull the valuable insights out of those while maintaining the kind of core basis that you can't train an AI data set without a lot of data? How do you go and find that data if the data is corrupted or otherwise pull out kind of implicit human bias of generational data?
I think I heard a question of garbage in, garbage out. How do we manage that? Is that about right, Will? Like, I mean, applying to a bunch of different scenarios, whether it be energy or markets or.
Looking at mainly like there are human actions that are then kind of the data is the output of human actions. No. So from that, how do you look at expanding AI into new applications while recognizing we have historical human bias within that and still being able to create value out of the data sets that we have?
Well, what you just described is that LLMs reflect humanity. Some aspects of humanity we're not proud of, right? So you're asking, how do we erase that part moving forward such that, you know, we are better as a civilization, as people? One way is, of course, to clean the data of the bad parts, but who decides what's bad? I don't know. There's synthetic data, basically creating new data reflecting who we want to be. And then I worry, are we in 20 years going to be somebody that we don't want to be? And you know, that gets too philosophical. But fact is, we can't change who we were, you know, as shown in the data that was used in training these AI models. Maybe.
Same as today.
One of the things that our largest customer, Will, by the way, is Providence Private Equity. They have 400 solar farms. And what we found the best way to produce, you know, the best optimizing of energy generation while also optimizing revenue to the spot market was this multi-agent approach, right? You take as much data in. They were focused initially on irradiance prediction. We told them that, you know, without understanding wind prediction, you wouldn't understand dust on the photovoltaic cells. You wouldn't understand, you know, the degradation therein. If you didn't understand temperature and temperature predictions, you wouldn't know about battery discharge rates, and you couldn't optimize at all until you started to get that context that you needed through a multi-agent approach. And so I think you use human beings in as much context as possible. And to Sasha's point, you live with that until you can steer it in the right direction.
We could take one more in the back of the hat. Yeah. Don't make just yell it out. Don't make LeBaron run all the way.
I was just, a lot of negative questions so far. And, was just hoping to get Mr. Sasha to talk about a little company called Fireside and some of the exciting things that have come out of that.
Farmwise, oh wow. Thanks for the shout out. That's one of our portfolio companies that we're super proud of. They build autonomous weeding tractors. So weeding is obviously a very important operation in agriculture that is most of the time done manually by day labor. You know, it's backbreaking work. Humans, you know, one thing about robots that they will hopefully relieve us of doing the dirty, dull, dangerous type of work. And Farmwise has built a solution for that, for the specific task of weeding, and they will then extrapolate that towards other agricultural operations, but they operate in Watsonville, in Salinas Valley, in Yuma Valley, in Nevada, so we're super proud of them. Two young founders from France who are immigrants, went to amazing graduate schools here and started a company and changing the world for the better by, you know, improving how we grow our food.
I love it. Thank you all. Before we wrap it up here, thank you all. But one of the phrases that we're excited about at AWS is undifferentiated heavy lifting, which is a theme that's run through all this. That exactly what Sasha was talking about. Why are we paying people to go out and bend over in the sun and weed when we could get a machine to do that and free those people up to go do really meaningful, impactful things for humanity and society, and within some guardrails and some boundaries that make sense, and we'll have to learn over time to get them there. And better yet, I hope no one in here is a taxi driver, but if we could get a machine to go do that and free the taxi driver up, perhaps there's a better opportunity for society. So I'm optimistic and hopeful. I hope you all leave here. I want to thank these three for getting up here and not knowing anyone, taking shots. Impressive. Well done. Thank you all.